Hello, welcome back. In today's episode, we're going to look more into sealed classes and interfaces. We'll also look at type aliasing in Kotlin. And lastly, we'll look at how to use constructors in Kotlin classes. Sealed classes and interfaces represent restricted class hierarchies, and they provide more control over inheritance. A sealed class will have all its direct subclasses known at compile time. There would be no other subclasses that can appear outside of the module and the package within which sealed classes are defined. A good example would be third-party clients could not extend or inherit your sealed class in their code. Therefore, every instance of a sealed class has a type from a limited set that is known when the class is compiled. A sealed interface would work the same exact way that a sealed class would work, but for implementation of contracts. In some way, you can consider sealed classes as advanced enum classes. The set of values for an enum is usually restricted, similar to how sealed classes are. However, enum constants usually only exist as one and one instance alone, whereas subclasses of sealed classes can have multiple implementations with their own state. Let us learn how to create a sealed class. You start with the keyword sealed. Provide the name. You can provide any set of parameters that you may want your sealed class to contain. For my case, I'll have 2. Subclasses of the sealed classes can be defined within the sealed class itself. Let us add some few subclasses here. There we have definitions of our subclasses within our sealed vertebrate class. We use sealed classes as a means of controlling every single possible occurrence of a given entity. In our scenario, we know that only 5 types of animals are vertebrates. Let us expand this example a little bit more. We can have properties provided into our individual subclasses. For example, for different types of fish, we can look for either if it is in freshwater or not. We can provide the property of lifespan. For our amphibian, we can have the lifespan provided. We can check whether our mammal is egg-laying or not. These parameters can also be passed into the constructor parameters in the sealed class that has been inherited. Let us also have another member of this specific sealed class. We can make this member private. This class will be used to provide information about 2 different vertebrates that have crossed. So let us call this generic vertebrate. It will also inherit vertebrate as the parent class. Let us provide some properties first. For this generic vertebrate, we'll check whether it is cold-blooded or not. We'll also be given a lifespan, and we can probably give it a name as well. And then provide the cold-blooded and lifespan properties. Let us also override the toString method for this specific generic vertebrate. I will use a string literal. Make sure you trim the indentation, animal, and then provide the name. Since we're using them as variables, let's change this to vals. After providing the name, let us now provide the lifespan. So now we've overridden our generic vertebrate toString method and provided a custom implementation when printed. Lastly, within our sealed vertebrate class, we can also define a behavior that is common for every single class, and this behavior will be known as cross. The cross behavior or the cross function will just be a simulation of when two different vertebrates breed. I'll provide it as an infix function. We have covered infix functions earlier in our course. You can go check out how they're used and what they do. So we are going to return a generic vertebrate, and we need to provide some properties. The first one would be the name. Provide the two names of the two animals that have been crossed. So I'll use the Java class name. So we have our name provided. The next thing that we need is we need to know whether this animal is cold-blooded or not. Before we do that, let us make sure that our sealed class has its constructor properties provided as variables so that we can use them within the class. To do this, we'll simply add the private val modifier. We can now provide our parameter for is cold-blooded. So this will be equal to. So we'll simply indicate if both of them are cold-blooded, then the generic vertebrate will be cold-blooded. If one of them is cold-blooded and the other one is warm-blooded, then the generic vertebrate will still be cold-blooded. Lastly, it will only be warm-blooded if both of them are warm-blooded. The last one will be the lifespan, and for the lifespan, we'll simply add the 2, and there we have our generic vertebrate. Let us try and run this example. Let us try to cross a toad and a fish. We can start with our toad, and this will be provided as vertebrate dot amphibian. Toads live between 10 to 12 years, so I'm going to put my toad at 11.5. We're also going to put a fish, maybe a trout, 5.5. And the fish also needs to know whether it is freshwater or not. Let's put this as true. And then last but not least, we can print out the generic vertebrate that will be produced once the toad breeds the trout. Toad cross trout, and we can try and run this and see. So there we have the animal is a generic vertebrate amphibian and vertebrate fish. Lifespan is 17. Warm-blooded indicates as yes. This needs to change. I think our condition was put in the opposite manner. So if cold-blooded, then the answer should actually be no. And then yes, if it is not cold-blooded. Okay, let us try and remove this set of characters here so that we're just left with amphibian slash fish. So we can head over to our name, and we can simply use the replace function. So the string dot replace, and we want to replace it with just a blank string. Now let us try and rerun. So there we have it. So we have a generic amphibian or fish. We can try this with something else. Maybe we can have, so we can cross the eagle with the cow. And then we rerun this, and we can see a generic bird or mammal, lifespan being 45, and the warm-bloodedness is a yes, since both of them are warm-blooded. If we attempted to cross maybe the eagle with the trout, so one that is warm-blooded, another one cold-blooded, same result is what we expect. So it won't be warm-blooded, lifespan will be at 35.5, and it's a generic bird or fish. Let us now look at sealed interfaces. Sealed interfaces are similar to sealed classes. The only difference is with interfaces, they are implementing contracts as opposed to classes that implement functionality. We can have a sealed interface representing a plant. Within this sealed interface, we can have several properties for each specific plant, maybe a name and a height. We can have member interfaces of this sealed interface known as plant. Within each individual one, you could have specific implementations of things that you want. Maybe you could want a cross function. And this one will get another plant in, and probably it will give you back a plant. Probably you want for this one to be renamed differently. Maybe you can call this breed, but the same idea within the functionality. And similar scenario, you can reuse this interface in different sections. So let's assume we have a class known as the mango. So mango can inherit our plant.angio. So mangoes are angiosperms. Sealed classes are very similar to enum classes. However, you may prefer using a sealed class over an enum class because sealed classes can allow you to provide custom implementations of different parts of the restricted objects. Enums can only offer you an opportunity to provide one and only one way of implementing a specific type. But for a sealed class, you can have varied ways of implementing your type. Your types can also contain bodies, and the bodies can contain custom functionality. We can also use sealed classes within when expressions with Kotlin. Let us take an example. So assume we have a variable. I'll call this variable crossed. So this will be the crossed animal. So probably eagle cross cow. Then we can have a when crossed. Provide the implementations of each possible type of cross. And since cross is of the type generic vertebrate, and generic vertebrate is a member of the sealed class known as vertebrate, we can provide each individual as an option. So we could have maybe when crossed is fish, we can do something. We can even use code completion to add the remaining branches. The one thing you'll notice, of course, is since we have generic vertebrate as a private member, what we can simply do is to provide this in an else block to satisfy the else expression. This would work the same exact way as you would with an enum class. Contrary to popular opinion, which usually say that members of sealed classes can only be defined in the same file as the definition of the sealed class itself, members of sealed classes can be defined outside of the same file, but must be declared in the exact same package. Let us try and create another file which will contain another member of our vertebrate sealed class outside of our main file. Inside our package, we can add a new file. Let us call this file custom vertebrate. We could have this inherit our vertebrate class, and we could have all these custom vertebrates maybe to be cold-blooded and maybe the lifespan at 10.0. As you can see, the definition will work. Head over to main. Then you can provide an alternative inside this when block. So if it is custom vertebrate, there's an extra inheritance restriction as well. If you're using multi-platform projects, members of sealed classes must reside in the same source set. It applies to sealed classes without the expect and actual modifiers. If a sealed class is declared as expect in a common source set and have actual implementations in platform source sets, both expect and actual versions can have subclasses in their source sets. Moreover, if you use a hierarchical structure, you can create subclasses in any source set between the expect and actual declarations. The main benefit of using sealed classes will come into play when you use them in a when expression, similar to how we've done here. If it is possible to verify that the statement covers all the cases, you don't need an else clause to the statement. In our case, we do have the else clause because this specific sealed class has a member that is private and hence not available in other portions of this project. When expressions on expect sealed classes in the common module of your multi-platform project will still require an else branch. This happens because subclasses of actual platform implementation are not known in the common code. Let us now look at type aliasing. Type aliases provide alternative names for existing types. As simple as that. If the type name is too long, you can simply introduce a different shorter name and use the new one instead. Type aliases give you a chance to make your code a little bit more semantic and concise. Let's look at an example. If writing the class name amphibian that comes from the vertebrate sealed class is way too long, we can simply provide a type alias for it. We can simply indicate type alias, provide the name of the type alias. We can have maybe AMP. This would be equal to vertebrate.amphibian. And with this, we can simply replace the AMP name anywhere we have vertebrate.amphibian. An example would be inside the when clause, we can simply now provide AMP, and that will still compile. We can also provide AMP when defining amphibian objects. And that would still work the same exact way. You can provide different aliases for function types. Let's give an example. If you had a function that requires some value and then emits a given other type of value. So let's assume you have two integer numbers that are put into the function, and then the output would be an integer number, and this would be required in different arithmetic operations. You can provide them with a name. So we can say type alias numeric op, and this would be equal to function that has an integer as one of the parameters and then integer as another parameter and returns an integer as well. If I had a function that, let's say, provides this type of operation, so we can just say op, and this can be the numeric op. Give our function a name, we just call this simulate. So I want to simulate a specific operation. Now what you can simply do is call your operation there. So print line our op. Since op requires two numbers, so parameter 1 will give maybe 10 and then parameter 2 give it 20. And then we can call this simulate function. Let's call simulate, then provide an anonymous function. So function which will have the first one being an integer, second one being an integer, and then we'll have it equal. So with this, you can simply run and you'll find the addition of the two numbers. So you can find it as 30. Let us now look at constructors. Constructors are considered functions that are part of the class definition and they are used to declare objects. Let us look at an example. Let us have a class known as person. This class may probably be defining a human being, and it will have several properties about this human being. Maybe their name and their age. So let us override the toString method. So this is one way in which you can provide the properties of this specific person object. If we head over to our main method, let us have the person, I'll just call p1 equals to, and then we can change the names. So we can say p1.name, have that equal maybe xyz, and then p1.age, have that equals to 23. Then let us have a print line of p1 here, and then print line P2 here, P1. And you will see that the first one will give you, of course, the default, which were the values we provided, gender and 22 as the age. The second one will give you XYZ and the age being 23. However, this is a very, very untidy way of providing these values. One way we can do this is by putting in the values as part of the constructor. To provide the properties, let us give a parenthesis and then set out the exact same properties that we have. Cut that, provide it in there. Now, what we do have is we can define any person with a different type of name and age as per our liking. So instead of us having to provide the edited values this way, we could simply create another person too and have the name equals to XYZ and the age equals to maybe 90, and we can print out person 2. There you have the values. The constructor of a Kotlin class is usually defined inside the head of the class definition. You can also have what we call initializer blocks. An initializer block is a portion in your Kotlin code that will be called the moment an object is created. Let us look at an example. Let us have a late initialized variable known as old enough. Make sure the type is a string. We have covered late initialization strategies in Kotlin in our previous episode. You can go check that out. We can then provide old enough. However, since the initializer block is called the very first time the object is created, the late init modifier is absolutely unnecessary. This was just a way to show you how it would work. So we can replace this and it would still work very, very effectively. Your class can also have secondary constructors. These are constructors that are extended from the initial constructor. Let's have an example. Assuming you also want someone to define the person object with an extra property, such as height. You could provide a secondary constructor that can allow you to do this. You'll use the keyword constructor, put in all your properties. So we'll have name, which is a string. We'll have age, which is an integer. Then we will also have the height, which you can put as a double. But you must inherit the current constructor and provide the exact values that are needed. So that is the name and age. Typo here to height. So within this secondary constructor, maybe we could use this height somewhere else. So we could probably have in centimeters, have this equals to be a double, of course, and then have this equals to 0.0 by default. And then we can put the initializer block next to the constructor as though it was a function body. So provide this and then simply indicate height in centimeters would be equals to the height provided. And then last but not least, we can maybe use the height somewhere. So we can say height and then provide our height in centimeters. Since this property is just used within the class itself, we can make it private. And now, if I wanted to use this person's height, let's say for instance, person 2, we can have them provide their height as 120.0, and then we can rerun. And now you can see, by default, the height is 0.0, but if I use the secondary constructor, I can now set the height to a different value. That was it for today's episode. We've learned a whole deal about sealed classes and their use cases. We've also learned about type aliasing as a way in which you can give more semantic names for your objects and your class definitions. And then lastly, we've reminded ourselves a few things about constructors. In our next episode, we will take the time to look at build systems. We will begin with what build systems are, and then we'll go on ahead and look at how Gradle, the default build system for Kotlin, can be used to power your projects. See you then.